Okay, this video is about the Poisson probability distribution. I'm going to give you a brief definition explanation of this distribution. It's very easy to use if you are using Statcrunch, even if you're doing calculations by hand. So the Poisson distribution is a discrete probability distribution that models the number of times an event occurs within a fixed interval of time, provided that those events occur independently and the average rate of occurrence is constant and will be given to you. So we use a Poisson distribution when events occur independently, events occur one at a time, and the average rate of the likelihood that this event will happen is constant across time or space. So the formula to use to compute the Poisson distribution is given by this formula. Probability of x equals x. Let's say he asks to find the probability of x equals 3. So you put e raised to the power of lambda. Lambda will be given to you. It's the average. E is a number. It's a natural number. This is the value of e, 2.718. Lambda, as I told you, will be given, and he's given you x. For example, it says probability of x equals 3. So then you replace x with 3. Let me show you an example. You could use Statcrunch, and I'm going to show you how to use Statcrunch to compute Poisson probability. Okay, let's look at this one. A small bakery receives an average of 3 online orders per hour, so lambda is 3. What's the probability that exactly 5 orders are received in the next hour? So we know the average is 3. We want to know what's the likelihood that we receive more than 3, 5 orders in 1 hour. So x is 5. So you just plug in x equals 5. It will be before we continue, I just want to bring something to your attention. The formula, it's e raised to the power of negative lambda, not lambda, but I said lambda at the beginning. So a small bakery receives an average of 3 online orders per hour. Lambda is 3. Find the probability exactly 5 orders are received in the next hour. So it's a probability of x equals 5. So it will be e raised to the power of negative 3 times 3, because lambda is 3 raised to the x, is to the power 5 divided by 5 factorial. You can see the x factorial at the bottom here. And then you can do the math, guys. You will get 0.1008. But let me show you how to use Statcrunch for this one. So let's go to Statcrunch. So we're in Statcrunch. You go to Stat, Calculators, Poisson. Okay, that's the calculator. Mean is lambda, and lambda is given to us to be 3 here, so just put 3. And what does he want? He wants the probability of x exactly 5, so just change this one to equal to 5. And here you go, we get the same answer, 0.1008, and it's highlighted. So the interpretation, there's about 10% chance that the bakery receives exactly 5 orders in 1 hour. Okay, the other example, what is the probability that the bakery will receive at most 4 orders in the next hour? So he wants probability of x less than 4. You can do this using the formula. At most 4, guys, means like 4 or 3 or 2 or 1 or 0. You can use the formula right here and plug in 1 time x equals 0, 1, 2, 3, 4, and then add them up. But Statcrunch can do it for you, so I'm going to show you how to do that in Statcrunch in one shot. There you go. All you need, guys, is just change the sign to less than or equal to, and just put 4. And look, static, not only you get the answer, but it you see visual of the answer. This is 4, 3, 2, 1, 0. All of them added up, and the answer is 0.8153. So the answer is 0.8153. Interpretation, there is an 81.5% chance that the baker receive at most 4 hours in 1 hour. And as you notice here, guys, I put the steps and using Statcrunch, so you don't have to do the work by hand. You can simply use Statcrunch. This is pretty much what you need to know in Poisson distribution.